Okay, so I'm David Hannaford, and I'm involved with UK Mars, and I've been building micro mice for 20 years, and I also do quite a bit of stuff with schools. So that's my main focus in terms of UKMARSBOT, having a robot that we can use in schools.
I'm Garry Bulmer. Been hanging around the robotics department at Birmingham City University since about 13 years, 14 years. And Pete Harrison and Tony Wilcox and David have been carefully nurturing my interest. My main interest has been educational. I've been a commercial company using stepper motor robots and things. But my kind of short-term interest is electronics to make UKMARSBOT even more fantastic.
My name's Peter Harrison. Currently, I'm the secretary of UK Mars, which is the UK Micromouse and Robotics Society. We've been going for a few years. We run an annual conference, Minos, every spring. Well, every spring except the last spring, clearly. And we also run robot competition events. So we run the UK annual Micromouse contest, and we normally have a November event as well. Primarily, I'm interested in Micromouse and have been reasonably successful in that over the past few years. So my focus is on speed and performance. And in previous existences, I have taught electronics and control and IT and things like that. So that's me and what we are.
Wonderful, thank you very much. So this is going to be a panel session once we're done with the presentation. And we're going to be able to take questions from the audience. So go ahead and ask your questions in chat in the meantime while we're going on whatever comes up, and I'll be able to repeat them back to our panel. But we also have the ability to go live and take video questions from you directly. So once they're done with their presentation, feel free to click that share button and come on and ask your question in person. But now I'll hand over to, I think David's going to be showing the presentation.
Hopefully.
Yeah, okay, cool.
Okay, so let's go. So we've already done the introductions, so I think we can skip through that one pretty quickly. So the format is, yes, I'm going to do a chat about the UKMARSBOT, and then you can ask your questions, and don't forget you can do chat at any time on the way through as well. So first of all, just want to say something about why we designed UKMARSBOT. We wanted particularly an entry-level starting point for hobbyists and schools, something that could be built relatively easily, but which could then enter a number of the UK Mars competition challenges: line following, drag race, wall following, maze solving. I'll say a bit more about those in just a moment. We wanted it to be fully open source, documented, so that everything was available, covering not only the mechanical and the electrical aspects of the robot, but also some of the programming side as well. And the idea was that it would use fairly simple technology in terms of just requiring basic soldering skills and a bit of mechanical assembly to put together. The base design consists of a main PCB, but there are various sensor boards that could be added to it to provide different performance, or you can add different components to do different things with it. So what is, or what are the Micromouse competition events? The main ones are the line follower, which is a fairly traditional line follower. We do a white line on the black background. Some do it the other way around, but it doesn't actually make much difference. And that's just a question of how fast you can get around the complete track. We have drag race, which is a head-to-head knockout competition. It's a 7.2 meter track. You have to get down it as fast as you can, and you have to stop when you get to the end before you hit the end bar. So it's a bit of a challenge there. It's not just about speed, it's also about stopping and staying on the line, and that's good fun. And then there are various competitions that take place on a standard 16 by 16 maze. We do wall following, which basically says you start off at one corner up here and you're trying to find your way through to the middle. Wall following means that there is a route that if you just follow the left-hand wall, you will actually get to the center. The next more complicated variant, and probably the most challenging, is full maze solving, where in fact there isn't a left wall route or any wall following route to get to the center. So you have to explore the maze, you have to find the center, you have to find a route. Then typically you go back to the start and you run as fast as you can from the start through to the center, and you get several goes at that. We run various different categories, so juniors, which are typically schools, students, and also seniors. Okay, so what does the UKMARSBOT consist of? Well, basically, as I say, it's a mainboard PCB, and it's a couple of sensor boards. There are some N20 micro metal gearbox, gear-mounted gear motors, get that right in a minute, which bolt directly onto the PCB, and typically use the standard 32mm wheels. You have the option of putting encoders on the extended shafts at the back, and Garry talked about those in his session just a little while ago in terms of increasing the efficiency and the resolution on those. What else do I have? Right, you need a processor. So in this case, we use an Arduino Nano. Why do we use a Nano rather than a Raspberry device? Well, it's got all the things you need in terms of ADCs and PWMs and everything else built into it. And it's nice and small and it fits on, and you can buy them for about £3 if you look around. So a nice, cheap, easily plugged in Nano. The one thing it hasn't got, obviously, is a motor driver. So we use the TB6612FNG motor driver board to enable us to do the PWM speed control on both motors and forward and backward direction. And then finally, you need a battery. And we typically use these 9-volt rechargeable batteries, and then the various sort of resistors, diodes, switches, capacitors, and a few nuts and bolts to hold it all together. Okay, so in terms of the items, I'm just trying to get rid of this thing that says sleeping tabs at the top, but I can't get rid of that, don't worry. Right, so yeah, 2 sensor boards. The line following board that clips on the front is a one with downward facing LEDs and photo transistors. So it's looking for some lines in the middle. What you can also see on either side of it are some little extension boards, and those are for corner markers. On the UK Mars line follower, we actually put some markers in to tell you when you're coming up to a corner, and they can help you just slow down in time to get around the corners faster. For the wall following and the maze solving challenges, then we have a different board, and that one has some sensors facing out at the front, and then also 2 not direct sideways but angled side facing sensors, which again send out a pulse of light, and then you read it back with a photo transistor underneath that picks it up. Okay, so how would you get hold of one or make one? We don't supply a kit, but what we do is make sure everything is available for you to find out where to get all the bits and pieces. And so on UKMARSBOT, we've got about 20 wiki pages where you'll find component lists, supplier options, detailed build instructions, circuit diagrams, pretty much everything you're going to need. For the PCBs, if you want to make your own or get them made up for you, then again on our GitHub page, we've got all the information there, including all the Eagle and Gerber files. So you can just sort of pick that zip file up, send that off and get some made. or if you just want an individual set of PCBs and you're interested in getting involved with or working with us at UK Mars, you can join the UK Mars Club and we'll give you one set of boards free. If you're a school, then we'll look at a deal for getting you enough for whatever you need for your project. Okay, next. Right, so how does it perform? Basically, with the line follower, here's a little bit of video clip of one of the school's line followers going around this year's line follower track. And as you can see, it follows the line very closely, and this is with very minimal coding in there. It would certainly be possible and not too difficult as well to actually learn the course and then go much faster on the straights. And potential speeds on this one are up to about 2 meters per second with suitable motors and a bit of tuned coding. Right, so let's go to the next slide. Okay. Right, so how does it perform in a maze? Well, again, here's just a little bit of a maze. It's one of my sample ones at home. And again, it just shows the wall following version, doing a bit of wall following, round through, going along, staying clear of the walls, turning around. And in this case, this one's running at about 0.4 meters per second, which is again about a fifth of its potential maximum speed with the 20-to-1 geared motors. You can choose all sorts of different gearings on the motors. Lulu and Fimaroni do 10-to-1s, 20-to-1s, 50-to-1s, pretty much any number you care to think of. If you go with a lower number, say a 10-to-1, you get more speed, but it's harder to control it. 20-to-1 we found is quite a good balance in relation to using the system at schools. And that's not gone to the next one, has it? Nope, let's find the next slide. There we go. Okay, and so here's a little bit of exploring being done in the maze. So basically what it's doing here, it's looking at all the cells in the maze, and in this case it would be mapping it all out, and then once it's mapped it all out, it can then work out what is the best way of getting from the start through to the final cell, and then getting back again, and then doing its fastest run. Okay, next slide. Right, that's enough from me. What I've put on this slide is just a bit more information. If you want to see some YouTube videos about maze running in the TechFest, that's the UK Mars 2018 competition, there's a link there. As I say, we run typically 2 competitions a year, and so the second and the third links there show you some line following, some drag race, some wall following, some maze solvers, a bit of everything. So as I say, if you want to know more about what this robot can potentially be used to do, the competitions that you can enter, have a look at those and that'll give you a good idea as to what Micromouse is all about. Okay, right, well that's enough from me, so I need to stop sharing now and take it back to there.
Wonderful, thank you very much. That was an excellent view from 100 feet of what this is all about. I still have loads of questions, but we've also got lots of questions coming in from the audience already, so thank you for that. The first questions are about the maze, and obviously my Pi Wars brethren are very interested in getting their hands on your maze. So Mark Mellor says, is there a waiting list for the travelling line following course? How do we sign up? And can you reasonably test or practice without a full maze? So about the courses themselves.
Who wants to answer this one?
Okay, so the traveling line following course it's a reasonably large cylindrical package. David would be able to tell you more because he's actually used it. It hasn't got as far as me yet. I've asked to be put last on the list because well, my stuff's never quite ready, to be honest. So it costs about 20 quid to send it on, and the idea is that each person who gets it then sends it on to the next one in a chain. The best thing to do, because I don't know the answer to the question, is to drop an email to me at secretary@ukmars.org, or to the chairman, Ian, at chairman@ukmars.org, and we will find out what the exact details are. I'm sorry that I don't have this information off the top of my head. I think there are one or two people waiting for it at the moment, and folks generally keep it until they've done with it. Clearly, if there was a big list of people, we would try and get people to move on a little bit faster.
Obviously, this is our. Sorry, I was just going to say this is our way of coping with the lockdown, so that since we can't run the competition as such, then at least we can run the line following competition by sending the thing around, and then people video it themselves and then put the video up on the UK Mars website. We can compare times and see performance.
That sounds very familiar. So what about the maze issue? That must be incredibly difficult to practice in lockdown.
Until a couple of years ago, all of my development work was done at home on a maze, which is 5 squares by 5 squares. That fits on a 3 foot by 3 foot, which goes to show how long I've been doing this. A 3 foot by 3 foot piece of 1/2 inch MDF. The walls can be made reasonably easily. I'll just disappear off view. Hang on. So you need a flat board, and you can make walls. These are made from 1/2 inch cheap plywood, slot cut in the end, and this white material is a strip. I don't know where it came from, to be honest. Some plastic strip from B&Q. But if you've got access to a laser cutter or something, then 3mm acrylic will do quite nicely, and they just slot into the posts. And then the faces, people paint them, but really that's just messy. It's easier to just cover it in self-adhesive white sign maker's vinyl, which you can buy huge rolls of and gives you a nice uniform finish without all of that mess and nonsense.
Posts can be 3D printed. Yeah, so posts can be 3D printed. Probably the trickiest bit is if you're building a big maze, just sort of laying it out and getting the holes in the right place. But at home, most of us have a small maze. I've got a 6x3, which is the one that you just saw on the little demos there. And you can set it up so that one corner is the start and the other corner or some other section of it is the center. And you can test out pretty much everything you need on a small maze of that sort of size.
So you don't have problems with people who've tested in their home maze and they find a situation in the full maze that they never encountered during testing, and it all goes horribly wrong.
Yes.
Yeah, that can happen. It's one of the great things about robot competitions, and this isn't just about us. This is Pi Wars and all of the other things. Is that you can only do so much at home on your own. Sooner or later, really, to learn a lot, you need to talk to other people. And so getting together to do contests is really, really important. Seeing other people's ideas in action, asking them questions about how they've done stuff. We've always found that people are extremely friendly and helpful, and you can ask them anything and they will tell you, what they've done and how they've done it. They're only too keen to show off what they've done, and you can learn a lot. And if you have developed stuff at home and it gets to the contest and it doesn't work, well, it doesn't matter. You've still had a great day. You've learned a lot. And perhaps the most valuable experience is the contest itself. That said, anybody who's testing stuff at home and then wants to go to a contest could do with a little forethought to avoid too much disappointment on the day.
That was actually the reason for this conference coming along, was that we have exactly the same thing at Pi Wars. Everyone wants to talk about what they've done and how their robot works and all this kind of stuff, but we never have the chance on the day of the competition. Everyone's running around like a headless chicken trying to get their robots through the events, and we never had the opportunity to share this kind of thing. So I'm really pleased to see that you guys have your own conference. And I was wondering if that's something that came around, substantially after the contest started? Because that was the way it was for us with Pi Wars. Or has that always been part of UK Mars?
Well, the UK Micromouse competition's been running since 1980, and I don't think we had the conference right back as far as there.
2000. The first one was in the year 2000.
Yeah. So it's been going for, a good while.
So while we wait for questions to come in the chat, I've got loads more questions myself. Oh, no, okay, we've just had another question immediately from Mark Mellors. How competitive is UK Micromouse? And how many competitors do you get?
We're not a huge contest. We'll get, depending on circumstance and where it is, we could get maybe 10 or 15, exceptionally maybe 20 in the actual main Micromouse contest itself. Across all of the events, however, we get quite a good turnout. I couldn't tell you how many exactly. Not quite sure what you mean by competitive. I compete internationally, so I would suggest that the UK contest is, if you do well there, you can do well anywhere.
And Brian says, as a sort of a follow-up question, how badly will I embarrass myself if I have a go? Do you have some beginners?
Yes, of course we do. We say it a lot to people. Those of us who've got more experience talk a lot to beginners and find out what they're doing and give them as much encouragement as we can. Because if you were to, fortunately, and back when I started, we didn't have social media and easy access to phone cameras and the likes like that, and so there's not much evidence for my disastrous early days. But trust me, you're not going to do any worse than I did.
Just a quick one in on the numbers as well. We typically have a couple of schools entrants, and they will bring along another 6 to 10 each. So there may well often be 20 school kids along, all with their own line followers, drag racers, and some of those will have maze wall followers or maze solvers as well.
Be worth adding that UKMARSBOT is part of our effort to get more schools and education and maker spaces involved. And so the point of going through all of the rigmarole of testing it all out is that we get rid of that for somebody who's just coming in for the first time.
Right. Okay. So this was where I was going to go with my questioning was, what's the relationship between UKMARSBOT and UK Mars? Do we can compete with our own builds of Micromouse robot rather than building a UK Mars bot, or like what are the limitations on the robot? Does it have a weight limit or a size limit, or can I just put anything that will fit in the maze into the maze? What's the baseline here?
You'd be surprised. Mark asked if it's a high barrier to entry.
Yeah, this is where I was leading with this.
Yeah, it's not really. The thing is that, as is the case for lots of robot contests all around the world, people have a variety of different skills. Some people want to do it for the electronics, right? We have one regular member who builds amazing robots, but he's not really very keen on the coding, and so they don't often run and do much, but they're fantastic. And I would love to have some of his hardware and put some of my code into it, for example. And so other people find that the actual building of stuff is really, really difficult. They don't have the skills or they don't have the resources, but they've got lots of ideas for code. Well, there's not much we can do practically, we felt, except maybe reduce one of those barriers, and that's to try and produce this robot. And the primary purpose of the robot was to make it possible for people to take relatively low cost parts, put them together in a flexible way so that they could compete in any of our contest events. So the same physical platform can be configured. This one's configured at the moment for running in a maze. Can be configured for running in a maze, doing the line following, doing all sorts of things. Yeah. We have designed it in such a way that we deliberately made the processor replaceable, with a plug-in nano, because people may not want to commit to putting that onto a board permanently, you can unplug it and put it into a breadboard and do some testing on that, right? Use it for
I don't know
something else.
about you. I destroy nanos on a very regular basis, so it's nice to
Right.
be able to take that out and replace it if I blow it up.
So not only that, the Nano was chosen because of its flexibility, and partly by coincidence, Arduino released a whole bunch of compatible boards. So you can upgrade your basic Nano and put a Nano Every in it, or if you want the Wi-Fi and the Bluetooth, you can put a Nano BLE in there, Nano 33 BLE. The same pinout will accept some of the ST micro Nucleo boards. And most recently, and part of the reason we're here today, we have started to build, or a couple of people, not we because it's not me, a couple of people have started to build Pi Zero daughter boards, which talk to the Nano and use the Nano just for the kind of basic motor control and sensor handling, but the intelligence will be living in the Pi Zero. And that sits on a little kind of mezzanine over the top here and just connects straight in to the serial port on the Nano. So we've tried our very best to make this as absolutely flexible as possible and not commit parts, hardwired onto the board where we don't have to. You could use it for sumo, you could use it for all sorts. To answer a specific part of the question, though, the constraints on the robot are that it must be no more than 25 centimeters wide, 25 centimeters long, and the height is unrestricted.
Okay, that's not really
and there are some really bizarre robots that have been put in mazes, trust me.
Yeah, we started to have a height restriction on Pi Wars when we had some enclosed courses. But before then, we didn't have somebody was mentioning a giraffe robot yesterday. It's never been done, but we have had some outrageously tall robots. The 25 centimeters is a lot of space to work with. Them. You can do a lot with that. You could certainly fit a Raspberry Pi into a mouse robot within that form factor. In fact, I've got a project at the moment personally where I want to drive motors with encoders and Mechanon wheels and stuff like that. And I'm having to use an Arduino or similar platform to handle the encoders. So there's that kind of thing going on now where I'm driving, I'm telling the Nano or whatever what to do. Actually, I'm using a Teensy, but the same principle.
It's one of the interesting things is actually the difference between the Raspberry Pi and the microcontrollers, and the fact that the Pi organization have just brought out the Pi Pico, which is in effect much more like the Arduino in as much it's a microcontroller, and it's got all the little dedicated bits in there for your PWM and your ADCs and all the other stuff that you think you might need that typically isn't there on a standard Raspberry Pi. So it might be interesting to see whether we can stick a Pi Pico on one of these as well.
Yeah, definitely, and I want to see a Teensy pin-out version as well. So I was going to ask next, the board's open source? Is it Eagle files or something that we can use to customize the PCBs of UKMARSBOT?
It's all been done in Eagle. I think 7.6 is the current version because that's the last one where you don't have to jump through hoops. Maybe 7.7 is possibly the last. But if you've got Eagle 7 or later, then yes, the design files are there. Or if you don't have them or you don't want to do it, you can just go and grab the Gerber files and have your own boards made if you wish. Everything that we have is on GitHub or is linked via the UK Mars website.
Lovely. Now, Rob is saying, notice the cells on the standard maze are 18 centimeters by 18 centimeters. So the 25 centimeter robot would have a great deal of trouble with that.
The reason for that is a lot of the early micro mouse actually looked down on the tops of the walls. So they had a body that fitted within the wall space, but then had like a T-shaped piece out over the top that looked down to see the walls below. And from that point of view, they could be wider, be up to 25 centimeters. But yeah, if you want to stay within the walls, if you're more than about 80 by 100 mil, which just happens to be the sort of Eagle sort of size that you're likely to be building a PCB with anyway. If you're bigger than that, you're going to have trouble in the maze anyway.
So, could you tell us a little bit more about the UK Mars Club, please? So you've talked a little bit about the conference and the competitions. Is this is a club that I can join and sign up to and be a subscriber and get access to it for? What's the deal with that?
It started, basically, we were running a weekly get-together up at Birmingham City University at Millennium Point in Birmingham. But again, that wasn't always convenient for everybody to get to. And again, particularly in the last year with the lockdown, what we've done now is basically say, well, we'll have a monthly Zoom meeting. Oh, sorry, not Zoom, it's Google Hangouts, I think it is. And we can sort of get together and swap ideas and bounce things around from that point of view. But in terms of the club, yeah, there is a membership, there's an annual fee to join the club. And as you say, you get a free copy of the PCBs with that. And it just allows you
physical PCBs.
Yeah, so you get the main board and the two sensor boards, the line following and the wall following or maze solving board, basically. So the fee there really is just so that we can cover our costs for things like that, and it helps towards the cost of the conference that, again, we would normally be running in the first quarter of the year.
Is it
And
rude
the
for me to ask
competitions.
what the fee is?
Okay. Sorry, I missed that one.
So is it rude for me to ask what the fee to join is?
I think it's £20, the current annual fee.
That's worth it just for the PCBs. You've got a new member. Fantastic.
Well, £20 gets you, all of the other support as well, and it pays pretty much for the cost of running some of our events, and it's probably less than half 1 month on your broadband, so it's not a bad deal.
No, not at all. No, very, very reasonable.
I'd say there's a question there about the half-size micromouse.
Yeah.
Basically, what this is if you just took the standard maze and you just divide all of the things in halves in terms of size, both the space in the maze, the size of the cells and everything, and then similarly the sizes of the mice themselves, then it's the same competitions, but it's doing it at, well, not just half size, it's actually quarter size if you're thinking of it in 2 dimensions. So yeah, it basically, it's the micromouse the size of a credit card or smaller.
So what kind of motors do you use on that? M20s are pretty much the smallest motors I've seen in a robot.
These are pager motors often. They're 6 millimeter by 12 or 15 millimeter motors. They are what you know the little tiny micro drones come with 4 motors on, those motors.
So they're effectively running at full speed to drive the wheels.
They're going hell for leather, yeah.
Yeah, wow.
They used to do some teeny little remote control ones as well, about that sort of size that you could buy for about a tenner. And they have 2 of those motors and a little gearbox in there. And I picked up a whole load of those from a demonstration where they were showing these, and they had a lot of them were breaking. And I said, "Oh, can I give you a tenner for all the broken ones, please?" And they said, "Yeah, that's fine. Take them away."
Nice. So often a lot of stuff about saving money comes up in firewalls. We're big fans of AliExpress and Banggood and eBay hauls.
Yeah.
So whatever we can do on the cheap. On which note, I was going to ask you seem to have saved a lot of effort in the construction here by structurally building it around the PCB. Is that right? Everything seems to be made out of PCBs, apart from the actual compute hardware and stuff like that. So,
yeah.
And so the motor brackets bolt directly onto the main board?
The motor mount is, you can use, I made sure that you can use the standard Pololu motor mount for the N20 motors. I should have had one ready in my list of props.
I think
these are the ones.
Yeah, it'll fit the absolute standard Pololu motor mount, or you can 3D print your own, of course. And one of the things which may not be apparent, because I know that the Pi Wars contests would not really, all of them would suit such a tiny robot, right? So the obstacle courses and things might be a bit tricky.
It is
But
tough.
by making your own motor mount or reversing a standard Pololu one, you can mount 60mm wheels outboard, kind of out here.
Sure.
Okay, so that if you need the bigger wheels, you can do that as well. And you can always, because they're not bolted straight onto the bottom of the PCB, there's a little kind of riser plate. You can have them anywhere. I'm showing you stuff which isn't on camera. You can have them anywhere vertically, and you can have the wheels, almost as far out as you wish to put them. So that was a design consideration as well. You're not going to run down a maze anymore doing that, but if you want to be running over an obstacle course, that's the way to do it.
Sure, we had quite a few people that had interchangeable wheels in Pi Wars previously for like when they need to do an obstacle course versus a controlled situation where they maybe using Mechanim or something like that. We have someone in chat, Brian Starkey, who entered a robot even smaller than that in Pi Wars with some success. I don't know if you've seen you go and have a look for Minnie Mouse on.
Is this the little white one?
Yeah, it looks like a computer mouse.
Yeah, right.
And I watched him driving that around the obstacle course and getting stuck on bumps on the terrain. But it did better than you might have expected. So I actually think that this is an entirely practical chassis for Pi Wars. I guess the thing that I'd be most worried about would be if the PCB itself is fragile in an event like Pi Noon, when it might get banged up against by a bigger robot.
No, I have crashed mine into metal posts at 3 or 4 meters per second, and it doesn't sound good, but it's all fine.
And these speeds are crazy to Pi Wars people. We have slow robots compared to your mice, I think.
Yeah.
So there's an element of speed challenge to solving the mazes there.
Yes.
The nature of the contest is you have to explore the maze, map it for the full contest, right? You have to explore it, map it, explore it until you believe you have found the optimum route for your mouse, which may not be the least number of squares, right? Because you may be able to run faster down a long straight in preference to doing a couple of corners, or you may be good at particular maneuvers. And then when your mouse, this is all autonomous, remember, when your mouse has determined what's the most appropriate route, it goes back to the beginning, and then it gets another 4 chances to run the best route as fast as it possibly can. And in top contest in Japan, fast really is fast. Top speeds up to 5 or 6 meters per second. It will corner. Mine at the moment will corner at around about 5.5 Gs. And straight line acceleration is it's actually limited because it tends to take off a bit, but 2 meters per second squared. So 2 Gs straight line acceleration. So yeah, they're quick. If you haven't, anybody watching who hasn't seen a fast Micromouse run should just put Micromouse into YouTube, and you'll see some remarkably fast robots.
I mean, the one thing that you would need if you wanted to run this in Pi and to do all the challenges is you would need to add a camera, and that's where, by putting the Pi Zero W on the top, it gives you the ability to hook up a camera as well and do some of the camera-based challenges.
Well, and we need some kind of remote control as well for Pi Wars, because there are some challenges that we just have to drive. Actually, that's not entirely fair. Some people have tried to do the entire event autonomously with varying degrees of success, I would say. But this is really interesting to me, the idea that you've got algorithms this complicated running on a nano, effectively. You have the nano storing the cells of the maze. There must be quite a lot of optimization going on here as well. Some smart programming.
You can do it in a nano. You only actually, the smallest amount of space you can store the entire maze in is 64 bytes of RAM. So that's not so bad. If you, the simplest The simplest direct method of doing things needs 256 bytes of maze of storage for the maze, and then another 256 bytes of storage to let you store an optimal map effectively. So yeah, it's not as resource intensive as you might imagine.
I wonder if that is optimal. What's the? We could have a computer science discussion there, but I need to go and have a look at how your algorithms work.
I mean,
Right.
basically, for each cell, all you need to know is there a wall to the left and in front of you?
Yeah, exactly. So that's 2 bits per cell.
So it's just 2 bits per cell, and you've got 256 cells to do. So you get 4 in a byte. So 64 bytes will hold the complete maze.
Nice. Except you don't actually need to store that for the very edge cells because you know that they've got hard walls.
No. But it's also useful to have another byte to tell you whether you visited that cell. In fact, there are a few other things that you'd like to throw in as well. But you can do it with a few hundred bytes if you're really pushed.
Well, yeah, I was imagining that the libraries themselves were going to be the hard part. But yeah, very, very interesting stuff. I look forward to reading your code. And I guess you're all writing C for these?
I've written all but one of my mice in assembler. In the last 20 years. Typically, a maze-solving mouse I can do in 1,000 lines of assembler. When I wrote one in C, which was my most recent one, having a go at C, it took me nearly as many lines in C. So I'm not sure that C is better, except it's obviously a lot more flexible in terms of moving it around between different environments.
I think most people from Pywars probably use Python or similar, although we do have some people using slightly more esoteric things. I think we've had a Go robot and a Rust robot. I'm not aware of anyone having done one in assembler, so that could be a lot of fun. I would love to see someone doing a bare metal robot on a Pi, because you've got an awful lot of CPU and RAM available if you don't have Linux running on there to do some really good computer vision stuff, for example. But no one's done it yet that I'm aware of. Brian objects to Go being called esoteric. We'll have to have a fist fight about that when Makespace opens again.
I think the other thing that's probably worth mentioning about Micromouse is because of the speeds, you need the sensors to be operating very quickly. And most of us are operating with a main loop that checks all the sensors, works out where it is, decides what it's going to do, and then sets it up again. And we're doing that probably 1,000 times a second. I know, Peter, on some of yours, you do it 2,000 times a second. And so if you're doing that, you actually need sensors that can also respond in that sort of time. That makes things like cameras with relatively low frames per second speeds not very useful. Although, there are mice that have been through our maze running on cameras and seeing where they're going, but it's really hard to get the high speeds. Even with time of flight sensors, holding them, the laser ones that you see now, and again with ultrasonics, none of those is quick enough if you want to be checking all your sensors 1,000 times a second. So most of us are doing it with quadrature encoders for the speed. Maybe I think quite a few of them these days will have gyros on them as well for helping to handle through the turns. But then again, typically using just light reflection off the walls in terms of amount of light with pulsed LEDs, infrared LEDs, because you can do that in 100 microseconds.
Right, I was going to ask you why you're using those instead of ultrasonics, but that's the answer, isn't it? You can do it more quickly.
I mean, you can't do ultrasonics in much less than about 10 milliseconds, where, we can do this in, we can do our sensors in easily in the 10th of a millisecond.
I should just point out that a few years ago, a Micromouse in Japan achieved the holy grail that people have been trying to do for a very, very long time, which is to solve the whole problem with a camera. If I could find the video, I would put a link up. So maybe I'll do that later. But essentially what he did is the camera raised up like a cherry picker, okay, in a boom arm. So the mouse would sit in the start cell, the camera would raise up high and take 3 pictures, one facing north, one facing northeast, and one facing east. He would then post-process those pictures and kind of undo the perspective distortion, determine from that where all of the maze walls must be, plot his route, and then just run straight to the goal. Now, to be fair, this guy may have skills that you and I lack. So he had on there 2 custom processors built into FPGAs. His own, it ran Linux in one of these, and his day job is designing the FPGAs that go into Canon cameras. So he has a somewhat extreme skill set, but he did it, and it went up. It took the pictures, put down the boom, and then just ran straight to the goal. And it's still only that big.
I'd just like to bring in Mark Mellors' questions from the. We've had these questions in the chat. I think they're really interesting. So can we deal with those on the panel as well, please? He had a question about PID control for the wall following, and also a question about the idea of, do you use dead reckoning for the turns, or do you still detect the corners as you run down the diagonal corridor? So can you cover those topics a little bit, please?
Pete, I think that's one for you.
Okay, so I only use PD controllers. A PID controller, well, let's go back a step. It kind of depends on how you decide to run the robot in the first place. If you are running everything on velocity control, then it's a PI controller. I do everything with positional control, and that only requires a PD controller. And the reason there's no I term in there is that it's not like you're trying to reach some steady state closely for a long period of time. Okay, which is what a kind of classic full PID controller is about. By the time you've got to some kind of steady state, the world's changed around you, and you've got to go somewhere else. And so there's nothing really much to gain from the I term when you're doing line following or when you're doing wall following. A PD controller is more than adequate. The robot, when it's running, is largely dead reckoning. So it's got feedback. Odometry feedback from the wheels on mine, and on one of these, when I fit one of the BLE boards, there will be a gyroscope which gives you all of the angular velocity information that you need, and so it's calculating from that where it ought to be at any given time. And like most systems, and this is guidance I would give to anybody who's building robots, first, which I was given along many years ago, first of all, make it all run well open loop, right? So if you want to build a robot that can go forward 5 meters and stop within a few millimeters of where it's supposed to be, if you can make that happen without feedback control, right, and then add feedback control, that's when you will get the best result. So I think the goal is to make everything work well open loop and then close the loop to kind of really nail things down. So my micromouse software, I should say, because it runs in several different physical devices, it's designed so that you can say, I want to go 2.5 meters down a straight here, and my expectation is that that's where it will end up. Now, things can happen, and so what you do with the sensors is you detect the falling edges of the walls as you go by, and you know where they must be, and you can use those to correct your position on the way. That can be pretty useful, but I think most people who are going for the performance will try to do it with as little external correction as possible. But yes, we make use of the falling edges of the walls, the edges of the posts on the diagonals, and every other piece of information we can get.
So on that note, does anyone use IMUs or gyros that you're aware of?
All of us.
Oh,
All
right.
of us in contest, if one's available, we use it.
The standard UKMARSBot hasn't got a gyro on it, but if you use the as Peter said, the upgraded 33 BLE, then I think that's got a gyro on it, and again that can potentially be used to give you a bit more performance and control getting around the corners.
We've been having a bit of a programming language discussion in chat while this has been going on, and Gary's advocated in favour of Go already. Does anyone use higher level languages on the micro mice, or are you all sticking to pretty close to the metal to get the performance you need?
Rob Probin's used MicroPython, and Pete been doing a bit of background work, and my interest is getting something like MicroPython onto UKMARSBot.
One of the other guys that runs a schools club does a lot of stuff with Forth, so he uses that. I think most of us use C for a good proportion, or C++ for a good proportion of stuff.
And Rishan's saying, is using Python normal? I guess by the sound of it, no, it's not normal at all, right?
But it's not wrong.
Nothing's wrong.
It's if you have an appropriate platform, Python would be fine.
Oh, Rob points out using standard Python as well.
Yeah.
Okay, we just have time for another couple of questions, maybe, if anyone else has got any more for our panel, or if there's anything else that you particularly want to share with us.
I was just going to throw in, there is actually an embedded Go, which would fit on the board that we've been looking at.
As a Rust station, do you have any Rust users? Have you got Rust using Rust running any micro mice yet?
I'm not going to say my Rust.
Okay, right. If you don't have anything nice to say.
No, we have been having a little.
Event?
We have had a
Our
little
next
discussion
event.
in about Ross in between some of the members recently. So basically, we're looking at what we run on the 5.0 in terms of what we put there, and then feed down to the Arduino below it.
Our next event, if you have a look on UK Mars website, then you should, unless I have been tardy, which is not unusual, you should find next events there. Our next meeting, online meeting, is we use Google Meet, and it's on I don't know, the first Tuesday of the month, I think.
Which might be the 2nd of February, Ian Butterworth is saying?
That sounds right.
Yeah. But anyway, if you can email at one of these two addresses I'm putting on the chat, and we will give you details and give you joining instructions.
And welcome you to the club.
Indeed. Oops, can't spell my own email address now, idiot. Right, so either of those will do, and we'll send you some instructions. We don't restrict the monthly virtual meetings to members. We would obviously love you to join up for a very low cost, but we have people from all over. We have a couple of folk from Portugal, and occasionally a couple of folk from the United States join in as well. So everybody's welcome.
Well, that is a fantastic note for us to end on, I think. It's been really great having you here. I hope that this is the start of a beautiful friendship between the Pi Wars and the UK Mars crowd. I know you've inspired me to check out how the other half lives and maybe try and build one for myself, albeit following your extremely detailed instructions by the looks of things. But maybe one of you would like to have a go at Pi Wars next year.
Oh, well, I'm already involved, you see. So,
okay, fantastic.
I've done Pi Wars twice, and we're doing virtual Pi Wars at home this year,
Outstanding.
although finding it quite tricky with the lockdown at the moment, and we're running a virtual robot club once a week with the school members. But we'll be looking forward to getting back to school so that we can carry on building bits, pieces, and put a course together, because we haven't got one of those yet.
All right, so it just remains for me to thank all of our panelists. David, Peter and Garry, thank you very much for joining us today.